Nerve poisons quickly immobilize the animal. There's no opportunity for escape. Although snakes can unhinge their jaws to devour prey larger than their heads, this young taipan has taken on much more than it can swallow. Its acute sense of smell leads it to easier prey. As well as a powerful nerve poison, taipan venom contains enzymes to break down muscle tissue. The snake's meal is being digested even before it's swallowed. Without fossil evidence, just how venomous snakes left the land is unknown. But some of the adaptations they had to make along the way can be seen in living snakes. One of them can be found in northern Australia's coastal swamps. Here, a rich supply of prey is offset by a challenge that faces all terrestrial invaders. The white-bellied mangrove snake specializes in eating crabs. The venom these snakes brought with them from the land was an important weapon against these resilient creatures. Just where to inject it on the armour-plated body is a minor problem. The soft elbow joint of the claw is the easiest target. Once the crab has been secured, more bites will go through its hard shell and the poison does the rest. But the snake also risks being poisoned here. Every time it swallows, salt from the water accumulates in the snake's body tissues. To answer this challenge, these serpents of the shallows have modified their salivary glands, enabling them to spit out the excess salt. But the true sea snakes made one more modification, and did so before they even took to the water. It's thought that the change came at a time when global temperatures fell, making the incubation of eggs more difficult. In response, snakes like the red-bellied black snake, which live in the cooler parts of Australia, developed a new breeding strategy: live birth. Live birth enables the mother to warm the developing embryos right up to the moment of delivery. Released from the egg, some snakes took to fresh water, some to coastal shallows, and some directly to the sea. Free of the land, the sea snakes were never to return. Unleashed into Australia's tropical oceans, they have prospered, diversified and spread. from Asia to the Americas. Right in the heart of their distribution lies a place that harbours more species than anywhere else. 500 miles west of Darwin are the islands of Ashmore Reef. A voyage to remote Ashmore is a venture into the lair of the sea serpents and a chance to see their evolution in action. Few have ever studied the sea snakes, but they are zoologist Mick Guinea's passion. It's a 3-day sail. The doldrum season will provide a 5-week period of calm to safely visit the reef before the tropical storms arrive. Ashmore is a protected nature reserve where life is dictated by the forces of ocean and sun. 3 tiny islands sit atop a reef complex 15 miles long. One side receives the brunt of the Indian Ocean's waves and weather. The sheltered lee side is calmer. In the reef shallows, water temperatures reach 95 degrees Fahrenheit. Mick and assistant Scott Whiting must seek out an area for study. What they need is a small patch of reef that offers the greatest diversity of habitat. They employ a manta tow to survey the complex. Plains of sediment support huge beds of seagrass, attracting grazers and with them, predators. Coral outcrops called bommies are dotted around like apartment complexes, offering food and shelter. Every part of the coral abounds in life. Everywhere there are sea snakes. At least 17 species inhabit the reef. Ashmore really is the sea snake capital of the world. The bounty of the area has long been known to fishermen, but other visitors are rare. This is Mick's 3rd visit.
Well, there's few places in the world where you could dive with so many species of sea snakes and so many sea snakes of each species. It really is a wonderland for any scientist.
By day's end, he's chosen a coral bommy around which to base his studies, and the next phase of research can begin. To find out how territorial the snakes are, Mick and Scott must identify individuals. But first, they have to catch them.
The natural history of the sea snakes really isn't known at all. It's only by spending time with them, observing them, following them around and doing some very elementary tagging work that you can actually build up a natural history for them. There's a great gap in our knowledge of understanding just how these snakes fit into the environment and their place in nature.
What makes Ashmore such a haven for sea serpents? And what is it about them that lets so many species coexist? Most of what is known about sea snakes comes from lab studies. Their isolation and dangerous reputation has meant that their behaviour in the wild has gone unexamined. More is known about the lethal chemistry of their venom than their disposition to use it. Although resting snakes are easily caught, they're still not happy to be bagged. Despite the risks, Mick has a relaxed attitude.